Hello, this is Dead Hamster, and today we're going to be doing Chapter 3 of the new Making a Mod video series. This will be covering the Capture the Flag game type that I've recently featured as an early preview in a video. We're going to be going over the code of the Capture the Flag game type, how everything interlocks, and showing each piece to kind of show how this all fits together. So, taking a look here, the first thing we need to think out, we need to have data structures to hold the positions of the flags, what model they have. So there was a bit of thinking involved into what data we were going to need in order to properly play this game. The things that I ended up coming on for each player, we're going to need to know if they're holding a flag, so that'll take a single byte. I could use a bit array to really get down and use a single bit, but we really don't need that much of little data, and we do need to have the data be aligned to a certain size, so really I would just end up with a lot of extra padding. Characters, single bytes will be the smallest data size we use. The flag held will use a single byte, as well as the team, what team the player is on. We use a short mostly for alignment for the flag timer. That also lets us go past 255 though. We could use an unsigned character. Then we have another short for the invincibility frames, like we've talked about in the golden coin video, and another short for the score that they have. Again, we could have used characters for these, but we do need the data structure to be a certain length, so that it made more sense to use shorts for some of these values. We also have the actual flag object. Now it might not be a flag, perhaps it'll be a key for keep away or a shell for some type of game type. We're going to use this objective object though. It'll have a position and a velocity. The object may be moving in the level, so we'll need floating point values for those. We could use a fixed point system and divide by 10, but again, we're not at a real loss for RAM here. We have plenty of memory to work with, so floating point values will make a lot of the math easier down the line. We have shorts for the respawn timer, so if a flag gets captured, it might take longer than instantly to respawn. That's an option. Again, invincibility frames for a flag. If somebody drops the flag, there will be a short amount of time where the flag cannot be picked up to allow for some fairness between all the players going after it. There will be a character for whether what player is holding the flag, as well as what team the flag is for. An angle value so that we can rotate the object and make it a little more obvious to look at so that it stands out. And then we have, this is called F3D, and this will be the address of the model data. So we'll actually set this in for each object, since certain objects will use different models, and this will let us assign those and then display that later on. The last thing in the struct is called a bump, and that's an internal structure that Mario Kart 64 already uses. This is to deal with collision with the geometry, and we'll see later how that works, but it's for collision with geometry to keep objects from falling out of bounds. With all of that, we were able to start our code. The first real step to beginning the game type, after the battle map loads, we need to place all the flags and set up the initial data. So that will be in place flags. If it is a custom level, we're going to check, we use hot swap ID as what set the custom level currently is. If it's 0, we're loading the original courses. So if it is a custom level, we'll load spawn points and objective points from that custom level. If it's not a custom level, we'll be using the original data. So when we go down here, we're going to do a loop through the player count. So for each player in the game, we're going to run this code once and set up and initialize everything. Again, if it is a custom level, the spawn points that we loaded earlier, we're going to set the player position to the position of the spawn point. For the Y, which is the height, we're going to add 5, and this is just to make sure that the player is above the level. They'll drop down and land on the surface, just in case the point might have been a pixel or two underneath instead of above. The direction we calculate to face the center of the level. So wherever the player is placed throughout the custom level, they'll be turned to face towards the center, and that will give a somewhat more even start to the match. If it is not a custom level, we would not run this code, so the players again would spawn at the initial points, and we would continue here. This is mostly to initialize the player structs that we have talked about earlier. So we set the flag held to -1. We'll use -1 to denote that an invalid object, so to speak. So right now they're not holding any flag. If it was the first player's flag, it would be the value 0. The second player is value 1, so on and so forth. We start counting with zeros. But because it's -1, that's to show that they don't have any flag currently being held. The flag timer, the invincibility frames, and the score we're going to set to 0. If it's team mode, if we're doing a team battle between two different teams, then we set the first 2 players to team 0 and everybody else to team 1. That means that player 1 and 2 are on the same team and player 3 and 4 would be on the same team. If we are not in team mode, we run whatever player you are is your team. So player 1 would be player 0 actually, player 2 is player 1, so on and so forth, because again internally we count using the number 0 to start. If it is not team mode, we're going to go through each flag for each player, and we're going to place it, we place the flag just behind the player and the base just in front of them. So we have 2, I'm going to scroll all the way to the top, objective objects. We have the flag and we have the base. So we don't actually need as much data for the base, but it's easy enough to use the same structure, so that's what we're going to do. When we go back to where we were, so if it's not team mode, if everyone's playing for themselves, each player will get their own flag and their own base, and the flag that they get and the base they get, I'm going to jump over to another function real quick. We have a flag for every player and a base for every player, a mushroom color that matches the player. So we will load up the flag based on what player it is, and then it's going to either get placed, there we go, at the position of the player, and then it'll be either in front of them or behind them by 15 units, and to the left or to the right by 5 units. And that just gives the camera so that it's not looking directly at an object when you start. And then that'll go through for each player. If it is, and then we go through and we set up the flag. So we say that nobody is holding the flag, the player holding is -1. The iframes, the respawn timer, that all gets set to 0. The angle we just set to the same angle as the player, and then it'll rotate from there. This is if there is for every other flag, I apologize. So we do the same things. We set the angle and the position. If there is not a player, so if there's only 3 player, for the 4th flag, we set the same things, but we put it way out of bounds. -60,000 is almost past the limits of what the game can actually draw for standard geometry, so there won't be any way for a player to get out that far. The flag will be out in the middle of nowhere, and it can not be gathered since there's not that player on the field. Now, if it's not team mode, or rather if it is team mode, if they're playing on teams, we go through the same thing, but we only set 2 flags. So we'll set player 0's flag and player 2 flag. Instead of doing a loop, we just set them standard, and that will give it a little bit of variation as well. Instead of being player 0 and 3 or whatever it is, those will be across from each other on most setups. The other flags get placed out of bounds, the same as our earlier loop. So flag 1 and flag 3 will have all their settings reset and then be placed way out into nowhere land. Same with the base, which will be placed out nowhere. So that first step will just run in the beginning of the game. It'll only have to run one time. And that initializes everything. It loads all the spawn points if it's a custom level. It places the flags and the bases where they need to be based on where the players are, and it sets all the values of there's no player holding the flag, the timers are all set to 0, the score is set to 0. We're ready to start a new game. So this is our initialize function. We're going to run this right after the map loads, and this will again just set up the game type so that we can start running all the functions later to actually play through. So going to our next function, we're actually going to be playing the capture the flag mode. So we will go through every flag that there is on the field, if there's 2 flags or 4 for 4-player, whatever the case may be. If the flags or the player, so because there's an equal number of flags to players, there isn't always though. I'll need to switch that code up a little bit. We found a bug here. We'll need to run 2 loops, so let's go ahead and do that right now. This player so we're going to run another loop, and this will be for the players, and if the player has any invincibility frames, we'll just take 1 away. Same for the flags. If they have any invincibility frames, we'll take 1 away, and this will cycle through and run each frame. The next thing we do is check for picking up flags. So we're going to look at every player. If the player is not holding a flag, we'll continue. If they already have a flag, they can't do anything. They already are holding a flag. That's their main task right now. So if they're not holding any flags, then we can check forward. If their invincibility frames are set to 0, so if they've been hit recently, their invincibility frames will be turned on. They can't pick up a flag again. It takes a second or 2 for that to clear out. Then we go through each flag. So we're in player 1 right now, and now we're going to check for every flag in the game. If this flag is not being held, so again, we're going to do a simple check. Does someone already have the flag? If so, we don't need to go any further. And if not, however, is it team mode or is it not team mode? If it is team mode, we're going to check if the flag's invincibility frames are 0, and we are going to then test if a player is colliding with it. So we need to check the player position and the size of the player, and then the flag position and the size of the flag. If they intersect, the player will pick up the flag. If it is the same team, excuse me, if it's not the same team, they will assign the flag held to this flag and the player holding to this player. So now the flag is being held by that player, and that player is holding the flag. All the data lines up, and we make the player go slow. We decrease the speed by 60. So they pick up the flag, they drive much slower, and now they have to try to bring it back to base. If they are on the same team, so if the team matches the team index, we reset the flag, and that sends it back to the home base, and that's your way of recovering a flag that's been stolen. And so you can knock the flag out of the player's hands, touch it yourself, it goes back to base, and you've defended your flag. If it is not a team mode, we do much of the same thing. I should probably move this check up here, actually. That way it takes up a little less space. So if it is not team mode, we do the same checks, but we are checking, I don't actually know if I even need to, I think the difference is, yeah, this flag, if it's the same flag as the player. So I might rearrange this a little bit so that it takes up a little less code space, but efficiency, this is fine. It's the same thing between these two. The difference is if it's team mode, we're going to check the team index. If otherwise, we just check if it's the same player to flag. That ends up being the same thing. So again, assign the flag, lower by 60, or reset back to base. Then we go into check scoring, but that is everything for picking up a flag and checking if it matches the player, and if so, assigning it to them so that they can then carry that flag. The next part here is check scoring. So here we're going to see if the player is holding a flag and is then going to collide with the base. So again, we go through every player and we go through a loop. We see if they are holding a flag. If they're not holding anything, we can skip past this. But as long as they are holding some type of flag, we should check if they're going to hit a base. Earlier, we did the exact opposite. We checked if it was -1 to see if they can pick up a flag. Now we're going to see if it isn't -1, which means they're already holding it. If it is not -1, we see all the bases. Excuse me. If the base team index matches the player team index, or it matches the the player value, these are actually the same. So I can clean this code up quite a bit. If the player base matches the player's actual team, we do a collision check and see if they're collided with it. If they have collided with the base, we score. So we increase the score by 1, whether it's your personal score or your team score based on team mode. The game flag player holding is set to -1. The respawn timer is set to the spawn time, however that's been determined by the game type. And then we reset the flag. We actually should be waiting to reset the flag until the respawn timer is 0. That's another thing for us to clean up. We change the speed to increase it by 60. The player has now dropped the flag, they've captured it, so we need to increase their speed back to what it was before. And then the final step is setting the flag held to -1 because the player is no longer holding a flag. So that, pretty simple. It's very similar to the picking up the flag code. Now we're just seeing if they collided with a base, and if so, setting a few values back to default and increasing the score by 1. Okay, so there's also dropping the flag. So if you get hit by a shell, a banana, a fake item box, a star, you're going to drop the flag. So we need to first see that they are holding a flag. If not, we're just going to skip past the function. That's old debugging code. We can get rid of that. If they are holding a flag, we are going to take the flag that they're holding, and we are going to set the position to the player position right above their head, 5 units up. We're then going to set the velocity to be a random number between -6 and +6. So we take -6 and we add a random number up to the value of 12. And so if that value was 12, it would be +6, and whatever value less it is will be less. We do the same thing between 8 to 16, and then we throw it 5 units up in the y-axis. So what this will do, it will pick a random value, either 6 units to the left or right, 8 units front or back, and 5 units directly up, and it will throw the flag in that direction, and then the flag will continue to move until its velocity eventually decreases to 0. We then take that vector we created and we align it to the player's angle, so whatever angle they are facing, it will now be aligned to that direction. We change the character's speed because they've now dropped the flag, so we increase it by 60. We set the player holding to -1. The iframes are set to however long your hit stun time is. This is a separate value from the respawn timer, but it serves the same function. This is the player respawn. The flag respawn is the respawn timer. And then we set the flag held is -1. And the iframes are also the hit stun time. That's supposed to be the respawn timer, so we're going to go ahead and change that. That is a spawn time. Oh no, okay, that is hit stun time. Never mind, I got two things mixed up. The respawn timer is not the iframes. Anyway, and that covers dropping the flag. So this will run anytime one of those earlier functions is hit. So if a green shell, a red shell, a banana, fake item box, anything that does damage to the player will run this function in capture the flag mode. And if the player is holding a flag, they will drop it and it will fall from the level from there. So we're going to look at drawing the game flags now, and this is probably going to be the most complicated function. This is handling not just displaying the flags, but also the velocity and the collision with the level as well. So to start off, we set two angles to 0. The only angle that we actually edit will be on the y-axis, where it rotates in a circle. The x and the z-axis we will set to 0. We're going to loop through each flag, and we're going to see if the flag is being held. If a player is holding the flag, we're going to see what that value is. Either way, right here, that's where we increase the rotation of the flag. Again, so the first two angles are set to 0. The next we increase by 2 degrees, 1 times 2. Then we go back again to the player holding. So we see what player is holding the flag. If it's not -1, then we draw the flag above that player. So we take whatever the position of the player is, we add 5 to the y-axis to put it above the player's head, and we're going to draw it at that position. If the flag is not being held, so if the value is -1, that means that nobody is touching the flag, we take its current position and we add the velocity. So in our last function, we talked about how dropping the flag will create velocity so that it will be tossed around the level. Whatever the position is on each axis, the x, y, and z, we just add velocity to that so that it will move that many units across the level. We then have to check for collisions. There's a few collision functions that we emulate based on the ones that are in the game already. These were used for objects like the shells and bananas. I mentioned earlier when we created the struct that there was a bump struct, and this is what is used for most of these functions. Check bump 2 is, as far as I know, an internal function. Yep. Yeah, check bump 2 is an internal function run by the game itself. This will determine, based on that bump struct, where the object is and how far it's penetrated through the surface mesh, and it will create the number of units to push it back in. So if you're 5 units below the level, your bump will be 5 units positive on the y-axis, which will push you back up into the level. This check bump 2 function will do the calculations that the game developers put up based on the current position and velocity and the bump data, and then it'll access the collision struct that is already loaded based on the level that we're currently playing. We then do this is called manual bump. This is a rewrite of one of the game's functions that will handle repositioning it. So we're going to take the position of the flag, and then we're going to take the bump data. So the flag's position is going to be, if they have any distance on the ZX axis and the ZX flag is set to true, that means that it has penetrated through a wall that is set up against the ZX axis and that needs to be pushed back. So we're going to take this value as well as the distance through and add that back to the position. I don't know the full details on how they calculate how the collision and how many units to get back, but they basically give us the values after that function is run, and we just have to push it back into place. Now if it's hit either the XY or the YZ axis, that would be vertical walls. We're going to do a bounce, so we're going to bounce it off the wall and push it back in the direction that it came from. That's fun math. Again, this is an emulation of a function the game already has. It involves a whole bunch of square roots and angles and vectors, and I'm not really sure how it works, to be honest. It's some pretty funny math, and it will basically take whatever angle you've tossed it at, and it will bounce it back at the inverse of that, so that you get a proper bounce off of that wall. It's not perfect by any means, but it is very accurate for what we're doing, so it works perfectly for our cause. We do the same thing again on the YZ, so any vertical walls will have a bounce. If we are on the ZX axis, that would be the flat surface, that would be like the road that you're driving on. We take the velocity and we decrease it by a good amount every time that it's on that surface. And so what that does is slowly cause it to come to a skidding halt as it makes contact with the ground and as the ground friction applies to it. If it's not on the ground surface, that means it's floating through the air, we run gravity. So the y velocity will decrease. If the y velocity is less or greater than 2 in a negative direction, we set it back to 2 to make sure that it doesn't just zip through the level and plunge down below, which will happen if you don't do that. Back up, if it is hitting the ground surface, we immediately stop the y velocity, and so this will keep it on the ground so that it doesn't, again, fall through the surface. So we've calculated the bouncing. It will bump off the floor and bounce off the walls and head back in the opposite direction, maintaining velocity until friction slowly applies and brings it to a halt. The last thing to do is actually draw it, and that part is actually pretty simple. We just take the angle of the flag into our last vector, the one that we didn't set earlier, and then we draw at the position of the flag, which has now been updated with velocity and bump and all sorts of other values. We take that angle, the rotation of the flag. We take the 3D model that we set at startup. Again, we set the flag to be the model based on the player, and then we set it to a 0.1 scale, 1/10 of a scale. For the mushroom, we do the exact same thing, except we set the angle to 0, so the mushrooms will always face the same direction. We should face this direction towards center, perhaps, so that way it's equal. We'll worry about that another time. Either way, same thing, wherever the base is located, the angle, the 3D model of the base, because we assigned a color mushroom based on what player, and then we draw that at 0.35 scale, so a little bit bigger because it is a small mushroom, and we want the base to be relatively large. And that is drawing the flags. It's also drawing the bases, but the real meat of the function is handling velocity and using the internal game functions to deal with bouncing off of the walls and colliding with the different parts of the surface map. That is probably the most in-depth part of it, and where the real code coming into place is. If you weren't able to drop the flag and pick it up off the ground, I feel like that would really stunt the gameplay and prevent the enjoyment that you really get from a good capture the flag match. When all this is put together and all the code runs and does its part, you get a really fun game type where you're able to play against the opposition, try to steal their flag. Battle modes were always a bit, especially in Mario Kart 64 at least, they were always a bit stale. There wasn't really a lot of fun gameplay you could have outside of just going to the top of the level and camping on an item box and then finding another player. I always had a lot more fun from the race gameplay than the battle mode, and I think that with different objectives and different game types, especially like the ones in Battle Kart, which has inspired this mode, you get a lot more fun out of it, and I'm hoping to put that into Overcard as well. Hope you guys appreciate and get something out of this look into the different modes and the code running behind it. I hope that this video has been interesting to you guys. If so, definitely let me know. Like, subscribe, comment, all those wonderful things. If you haven't already, join the Discord server, and we would love to get some feedback and input onto other things that we should be looking at, where we can go next. I want to thank all you guys, as always, for the support. It's greatly appreciated knowing that your work is liked and looked fondly upon, so thank you guys so much for that, as always. And until next time, you guys take care.